So I guess what I was trying to get across was just as you can call occupation.head and get a single users, right? You can get a single column, as we've seen before, by calling the data frame and then a particular column. You can also do that on a filtered data frame. So this is my new DF, and this is my occupation. And you can kind of even make this crystal clear by actually taking the explicit step of calling a new data frame and then filtering on a specific column, and obviously you get exactly the same results. So this ability to take a set of filtered results, save it, and then do more stuff with it just shows the flexibility and the real capacity of what pandas is able to do. And certainly when I came to Python from my background in Stata, never had the capacity to do this before, and it was really opened up a lot of worlds for me in terms of what I could do on the fly with my EDA. And likewise, just as I have this new filter, and I'm going to keep the long syntax because I think it's useful to see it, you can call any other method on this. So I can call that filtered set, and then I can call occupation, and then I can call value counts. And here I have the list of 64 students, 4 other, 2 none. And take a look at how this is different from the other value counts. Previously, I had users, occupation.value counts. And it's really quite different. Not only are there more categories, librarian, writer, executive, scientist, but even for the categories I have, the numbers are different. Originally, there were 196 students, but in my filter data set, there were only 64 students. And of course, the reason for that is because I have filtered down to people who are, 19 or younger. And any other method that we've seen, even for example, .describe, well, the occupation doesn't really allow itself to be described too well, but let's see what happens if I call that. Yep, sure enough. So 77, 7 unique, the most frequent is student, and 64 students. So you can call all of these dot methods on the subset of the filter. Multiple conditions. So we can call users, as we did before, age less than 20, and then I put all of that into brackets, and I specify another filter, which is users gender is equal to male, and now I have young men in the data set, and I would probably want to call maybe .tail on that, or .describe, or something like that. Instead of the ampersand, you can have the pipe. So this is either young people or men in the data set. You can also filter on a predefined list as follows. So say our list of occupations is doctor, lawyer, and student. And then we can filter on this using users, occupation, .is in, in parentheses, list of occupations. And here it'll give the entire data frame of anybody who is, as we see, a student or a lawyer. Lots of students, a few lawyers, there's 1 doctor, et cetera, et cetera. And if you wanted to do additional filters on this, for example, you could call just the gender of each of these, and then you could call the head of that, and so on. And it's just another filter, so I could put all of this into brackets, rather parentheses, and then do another ampersand for another condition, etc. Sorting results. So let's sort the entire data frame by one variable or column. Column variable, same difference. Users dot sort values on age. And here we have the youngest individual at 7 years old, followed by a 10-year-old, an 11-year-old, etc. And let's go ahead and shorten that up. Default is ascending. You can also choose descending order. Ascending, as we've seen before, is equal to false. And now we've got the 3 oldest people at the top. And by the way, for what it's worth, this actually happened to me not too long ago. It's a kind of a common job interview question when you're interviewing for a job where you have to demonstrate knowledge of Python, and pandas in particular, to ask questions like they give you a whiteboard and they say, okay, with a whiteboard marker, suppose you had a data set of customers, how would you display the top 3 oldest or youngest customers? This is what they're looking for, is that your knowledge of being able to use sort values. The dot head plus the 3 is just a quick way to get the single oldest or the single youngest.
Could you also do, sorry,
yeah.
3 oldest? Could you say age, ascending equals true, and then tail?
Yes, yes, yeah, excellent. You certainly would. Exactly the same results. Except for that the 73-year-old is not at the bottom instead of at the top.
And is the index, is that supposed to be the user ID, or because there's 2 indexes?
Interestingly, there is an index and there is also a user ID, and they are clearly not identical. They're off by 1. At some point, some sort of data cleaning happened. Probably an individual was deleted from the list, and a new index was created, and that happened before we inherited the data set. But for what it's worth, set a column as the new index users.set index user ID. See, I'm doing this by memory, see if I got it right. Sure enough, and now user ID is the new index, and the previous index has disappeared. But because I did not use in place, if I call users.head, that has actually disappeared. So either I would need to redefine users is equal to users, or I would have to use in place for that to actually work. Great question. Okay, and I need to switch over to the other one, but let's see, I'm almost done here. Yeah, group by is the last big thing in here. And I think we saw using group by previously, but group by it's pretty much one of the most frequent techniques that you'll use, not just in Python pandas, but really in any data analytics tool. SQL or an Excel, a SQL that is called group by. In Excel, it's going to be pivot tables. R has its own version of group by. This is really frequent for data analysis, and you'll see it in a lot of the examples that you get from me for obvious reasons. Group by, the definition is, and here I'm going to actually put this as markdown. Group by aggregates a numeric column by a categorical column. Potentially plural. So, for each occupation in the data frame, count the number of instances or rows. So users, occupation, dot value counts. We've seen this before. This is not new. And I'm just going to give the first few here, keep it short. There's another way to get this information, which is users dot group by parentheses occupation. Now this code by itself produces something, but not something I can use. It has grouped the data frame by the occupation, but I have not passed it any aggregating method or thing to be aggregated. So let's go ahead and aggregate the user ID column using the count method. And now we'll get similar information to what we had before: 196 students, 105 other. Likewise down here, 196 students, 105 other. It's the same information, but this time it is, I was going to say sorted alphabetically, and it is A, D. Yeah, this is sorted alphabetically. Whereas this one was sorted by frequency. So the default is sort index and paste this 3 times. The default is the same, so line 1 is the same as line 2. If you wanted to sort by the values, this would give you exactly the same information as value counts. So you see we've reproduced value counts. This line of code that we saw earlier can also be reproduced with this line of code. Of course, it's a lot more code, so why would we want to do that? Where's the efficiency gained in doing that? And I'm actually going to add the head onto this. The efficiency is that group by will allow us to do a lot more things than simply getting the value counts of our data. Because in addition to counting, I can call a lot of other things. So for example, I'm going to bring this back. And now instead of user ID, I'm going to call age, and instead of count, I'm going to call max. And now this will tell me for every occupation, what is the oldest person in that occupation? Or the youngest person in that occupation? Or the average age of every occupation? Sorted on values, because the default is to sort on index. And now I can see that, no surprise, students are the youngest occupation with an age of 22. And people with no occupation are also young at the age of 26. The components of group by are the categorical variable, occupation, followed by the numeric variable, age, followed by the aggregation step. And here the aggregation step or type or method is exactly the same thing that we saw earlier when we did describe. So here we have the users age dot describe. And we saw count, mean, standard, min, max. Any of those will work, plus a few others. So I can call the median, or I could call the standard deviation, or as we saw previously, the count. And the quartiles, you can also get quartiles. I actually forget how to do that. But these are the most common ones. And above all, mean is probably the single most frequently used of all of them. Yeah?
Question. I had set the user ID column to be the index of my data frame.
Yes.
And then when I tried to do, I could just scroll up a few cells.
Yeah, so here I was using it as its own variable.
Yeah, is there a way to use the index there? Because I tried to pass user ID in because it was not the index and not its own column.
I don't think that there is, but let me try it just to be sure. I could be wrong about that. If there were, it would be .index. Doesn't like that. Oh, yeah, I didn't think so. Yeah, I don't think there's a way to use the index for that.
Okay.
And that's actually part of the reason why when I answered the question, I didn't actually run my code because I knew I would want to keep the data frame the way it was.
Right.
Do you know how to get out of that and get back to the original state? Yeah, just have to read back in the, exactly. Okay. So all of these are group by methods. Very important, very powerful method. There are, I believe, 6 different aggregators you can use. Min, max, mean, median, standard deviation, and count. I'm going to bring this in a separate one. And 2 ways to sort a group by. So going here with the mean, the 2 ways are sort values and sort index. So obviously it's sorting either by the index column, which is administrator, artist, doctor, or by the values 38, 31, 43. And each of these can also have its .head method to keep things simple and concise. And either of these can also be specified as ascending is equal to false. Okay. You can group by multiple variables. So what are your variables again? Let me take a look here. Okay. Multiple, don't keep in mind that they always have to be categorical. You cannot group by numeric variables. So using my earlier code, I'm going to group by occupation, but I'm also going to group by gender. And this will tell you the average age of administrators who were male or female, of artists who were male or female, etc. We could even, this would be not helpful, but you could add zip code in there as well, and then you would have a really massive set of data where you have the average age of men and women by occupation and by zip code. So maybe if you're working for like Bureau of Labor Statistics or something, you might end up producing something like that. You can also aggregate multiple numeric variables. So going back to our earlier simple one, just an occupation, here I was aggregating age, but maybe I don't just want age, maybe I also want, well, really, there is no other numeric variable here. Well, I guess user ID, but that's sort of meaningless, but just so you get the idea. And now it will display the average user ID and the average age for each one of our occupations. And of course, you could have done them together, both multiple numeric and categorical, by adding gender in here, and then you get both. And finally, you can choose multiple aggregation methods. So going back to the original, here I chose mean. But suppose I want to display both the mean and the median. Then you type ag for aggregator. And in parentheses, remember there are 6 you could choose from, and they are mean, median, min, max, standard deviation, and count. For some reason, you can't call mode. I thought that would have been a normal choice. Mean, median, and mode are the big 3, but it's actually not a built-in method. And any subset of these. Okay, and finally, a few other lesser used pandas methods, just to kind of have them in your repository. Recode values as follows. There's a whole bunch of ways to recode values, and we'll see more of this in a little bit. But let's create a new column, and we're going to call it is student. We're going to set this equal to users. Whoops. Is equal to users occupation dot map. Dot map is the name of the method, and it has nothing to do with like cartography, but rather it means I'm taking this value and I'm mapping it to a new value. So in the original set, we had, no, actually, this is, probably student is not the best. I should stick with the original one. So we're going to call this one is male, and we're going to remap gender. For remapping student, we need something other than map. So we're going to map, and for this we'll have a dictionary. What previously was female is now 0, and what previously was male is now 1. And then if I call users.head, I can see I have this new binary 1 or 0 for male or female. So dot map is really nice when you need to recode everything explicitly. It's not so useful, say, for something like occupation, where there are many, many possibilities, because then your dictionary can become quite long. And there's a more efficient way to do that, which I'll introduce in another notebook. And duplicates, there's a whole bunch of duplicate methods, but basically users.duplicated will show you a Boolean anytime any row is duplicated anywhere in the data set. And we can use that information to count the number of dupes in our data frame, similar to users.isNull.sum, right? Remember that one? You can also do users.duplicated.sum, and it shows me that I have no duplicate rows any place in my data set. Okay, so let's... Yeah, in that case, all of the columns. But if you only wanted to take a look at a single column, look at 1 or 2 columns, then you would have users.duplicated. And here you would specify the columns you want to look at. So suppose we're curious about anyone who has exactly the same age and the same gender and the same zip code. That should be fairly rare, right? And then we call .sum on that. Now there are actually 13 individuals of same gender, age, and zip code. And if you wanted to know who they were, you would just get rid of the .sum. And you've got your Booleans. Actually, let's go ahead and display how would you take a look at exactly who they are. I would take my users, I would filter it, and then I would set that filter to the Booleans that I had defined previously, and now I can see who they are. I'll add a comment on that. See who they are. Okay, that was a lot of information. Can we go 15 more minutes, and then I'll turn it over to the class exercise, independent exercise, and at that time, if you need a break, obviously, you can step out at any time as well. You may want to save and exit out of full screen. Back to here, and now we're going to switch to the UFO data frame and take a look at a few other methods. So once again, I'm going to start a fresh notebook. I'm going to call this O2 class notes UFO and EDA on the UFO dataset. Import pandas SPD. Import OS and from pathlib import path, and I'm going to call my data frame UFO is going to be pandas.read CSV, and let's build that file path as path.joinPath. So I'm doing this all in one line of code, what we've done previously. Parent data UFO.CSV UFO.head. There we go. So all of this, in the previous notebook, we broke out into multiple steps. Now, for what it's worth, this is the industry best practice way to do it. But of course, you can just do it the shorthand version, and you will see this in my code and other people's code. Just read CSV data UFO.CSV. And that actually also works just fine as long as the file path is the same on your computer and maybe somebody else who's also using your code. So now that we've read in our data, and as we can see, it's UFO sightings. It's got the time, it's got the state, it's got the shape reported, the color reported. First thing I would want to check is missing data, and UFO.isNull.sum reveals that colors reported has a lot of missing data. How much? I would wonder about the shape of the data frame. So out of 80,000 UFO sightings, 63,000 are missing the color. So there's a lot of missing data on that one. Also, column names are UFO.columns. And we see that a couple of them have a space in the middle. That can get problematic when you have spaces in your column names. So let's rename those columns with UFO.rename columns is equal to, and instead of, I'm just going to go ahead and copy these in here. Colors reported, I'm going to rename this colors reported. It is best practice with pandas to use all lowercase, though that rule is frequently not followed. And then I'm going to use in place equal to true and UFO.head. And now I've got nice, clean column names, color reported and shape reported. I'm looking at the solution notebook. There's a whole bunch of nice examples of filtering, similar to what we did with the other one, but I'm going to skip those because it's just retreading what we've seen previously. Dropping missing values, always kind of good to have. We could, but actually I want to recode some of those. Well, let's start with filling in A. Let's replace the missing values. So we had UFO dot fill in A, and so I actually don't have the code for that one in front of me. I'm just going to go ahead and skip that because I want to make sure that I'm giving you guys the correct code at all times. Okay, using LOC to select rows and columns. So the LOC and the .ILOC are two frequent methods for selecting rows and columns, similar to filtering. Select one column, all rows is UFO.LOC, all rows, but a single column. And select two columns is similar, but of course, instead of specifying just city, you need to specify it as a list and call both city and state. So the way the syntax works is the colon means all rows and the list indicates all columns. Of course, if I wanted to select certain rows, then I might say, 5 through 10. And now I've got index starting at 5 and up to, but not including 10. And again, I could have both city and state. So this is a quick way of selecting your data. When would you use this? You would use it if you don't want to filter by a condition, but you literally want a block of data. You know, like in Excel, you can just go to the spreadsheet and select kind of a whole section of rows and columns. That's what LOC is designed to do. And the ILOC, .ILOC method is similar, but this is when you don't even know the names of the columns. You just want the numbers of the columns. It's exactly the same, but so here are 5 through 10. And then I also want columns 0 through 3, for example. It's the same thing, but now I'm specifying my columns with their numbers. The I stands, I believe, for index, if I remember correctly. So this allows you to quickly select kind of a block or chunk of your data without applying any filters to it. And the last thing that I'd like to talk about would be, and there's actually in the solution notebook a whole bunch of different examples if you'd like to practice the .LOC method. The last thing is date time features. There's actually a lot of good stuff in here. Date time features with pandas. So we have a date column, and it is UFO. It's the time column, but it's not actually a date format. Type UFO time reveals that this is a series. That's actually not what I wanted. I wanted UFO time dtype. Shows that it's type object. We need to convert it to a date time object. So convert a string to a date time. This only works if it's already written out as a date time. You can't convert the word triangle to a date for obvious reasons. But because the time clearly used to originally be generated as an auto date and then became a string, we're going to bump it back to the date time format as follows. UFO new time is equal to PD to date time, and then give it back the original time column. And this takes a minute to run because it's a bit slow. Compare with UFO time and new time, and you'll see that the original time has these slashes, but now it's been converted into a pandas date time format. And now when I call its dtype, comes afterwards. Now it's telling me that it's date time 64. I'm not sure what the 64 is for, actually. But I believe that is the number of decimal places that are included in the seconds. So it's different. Previously it was date time 0. Now it's date time 64. And pandas can create a bunch of cool new variables from dates. And this is a really handy, neat pandas trick. So because it's already in the datetime format, now it can create components of it. Here, let me call out UFO.head first. UFO.head. Remember, this is what it looks like originally. So now year, I'm going to create a new variable. I'm going to call it year. And this new variable is equal to the time variable, the DT method for date time, and then the year attribute. And now when I call UFO.head, oh right, because it's not time, it's new time, of course. Now I've got a new variable that has simply called out the year from my previous one. And if I wanted to, I could group all of my UFO sightings by the year when they happened. So let's get some year stats. UFO.group by year. And the thing that I want to group, it could be anything. Let's just count time, for example, unique time.count. And here in 1930, there were 2 sightings. In 1947, there were 41 sightings. All the way down to 2014, there's about 5,000 sightings. Or maybe if I wanted to know what was the year with the most frequent sightings. Oh, that's actually not what I meant to do. I need to do count and then max. 7,000 some sightings, and I forget which year it was. If I call the index, I believe it will do that to me. It will not. Let's create a few other variables from this. You can also create the month using the same code that we did earlier is equal to UFO.
Can I ask a question while you're filtering on time? I'm just wondering in the index there.
Over here?
Yeah.
Like, why did that not work?
In theory, this is assuming that no 2 sightings happen at the exact same time.
No, what this is doing here is, and the reason this errors is because the dot index is on this entire thing, not on the data frame.
No,
So-
I mean the second term, I do year and then time.
This.
Yeah.
Ah, sure.
That's assuming that there's no 2 times that are identical for doing this count.
Oh, I meant to group on. Assuming. Yes, it is assuming that there are no 2 times that are identical. Exactly. Which I.
It's just like a proxy for like a sort of an ID, like if this thing had a event ID number or something.
Yes. I wonder because this does not have an ID, I wonder if we can do this on the index. I'm actually not sure, but that would be handy if we could. And we cannot. Okay. But yes, so yeah, it is assuming that this is going to be unique. So for example, shape reported is not unique, so though it will give us a result, it won't give us a very meaningful result. Sure, good question. So to create month, you do the same thing, dt.month, and then call UFO.head. And now we've got a new column. The month is 6 or 2 or 4. You could also create a few others here, so we're just going to keep the same code to show all of the different ones that get created. You could create month, you can create day, you can create weekday, so 1 through 7. Now weekday shows you that, for example, a lot of them will happen on the Sunday is 0, Saturday is 6. Or even the hour of the day. And a lot of them will happen at night, 22, 20, 19. I'm going to do one more group by statement and then I'm going to stop. So what is the most common hour for seeing UFOs? UFO dot group by hour and again, let's assume that time is unique. I'm not sure that it is, but I think it probably is. So hour 21, which is, since we started at 0, would be around, what, 10 o'clock in the evening, is the most frequent. Probably mean it would be more useful. No, you can't do mean, you have to do count. And yeah, it's definitely the evening hours, 21, 22, 20, 23, all of those are most common. Or if we chose to sort index, then it'll show it in order from midnight, or 1 o'clock in the morning. Looks like around 11 o'clock at night is when you see most UFOs, and 8 o'clock in the morning is when it's very unusual to see UFOs. So this is where kind of the group by method gets used together with those date time options to do an additional analysis. Let me go ahead and stop there. It's 8:05. For the last 25 minutes of class, there is a recap, which I'm going to put up here on the board, which shows most of the, in fact, all of the commands that were used for the user's data frame. What I'd like you to do is choose a new data set from the data folder. There are a bunch to choose. And try and carry out these same commands. Read it in, call its columns, its D-types. Try building a few filters, describing them using the different types, value counts, more filters. And your final output for the map command, once you display that, go ahead and post that on Slack to let us know that you finished, or as far as you get. Okay. So choose a new data set, run it through its paces. And definitely call me over if you've got any questions or things you want clarified.